Okay, so now let's continue with the gas problem here, and what we're going to use a lot with any gas problems, ideal gas or otherwise, is going to be our ideal gas law, where pressure times volume is going to be equal to moles times R, our gas constant, times temperature. And so a couple things there. R is 0.0821 liters times atmospheres, moles times Kelvin, which I'll give you. And temperature is always in Kelvin. Okay, so anytime you're doing a calculation with temperature, it's going to have to be in Kelvin, which you just take Celsius and add 273. Okay, so in a lot of these problems, so if you're given all the variables except one, and you can just rearrange this equation and calculate the final variable. In a problem like this, we just have two variables. We don't know a lot of the other ones. We have moles and we have volume. And so what's going to happen to this is that the other variables, other than the two that are given, are all going to be constant. So R is always going to be constant. Two variables are going to be kept constant. So in this case, we're assuming that temperature is constant, and we're assuming that pressure is constant. So the flexible container means that we're going to change volume to accommodate our change in moles to keep the pressure of our vessel constant. And so in problems like this, and you can do this with no matter what two variables you're given, if you start with this ideal gas law, you can figure out what you need to do. So we have moles and we have volume. And so what I like to do is let's get all the variables on one side and the anything that's going to remain constant on the other. So pressure, R, and temperature are going to be constant. So we can get pressure, R or RT, would be equal to moles over volume. Okay, and so between N1 and V1, so the first situation, and our second situation, this is going to remain constant, which means N1 over V1 is going to be equal to N2 over V2. Okay, in this case. And so once we rearrange this equation, what happens is that all we have to do is plug in the values that we have. So the only thing I'd warn you is if it is temperature, remember to have temperatures in Kelvin, but in this case we don't have to worry about that. We have 3 moles at a volume of 7 liters, and so if we change that, if we have something with 5 moles, what would our volume occupy? And so if we do that, our volume is going to be about 11.7 liters. Okay, and so this makes sense. So if we increase the number of moles we have, we're going to need a bigger volume to keep the pressure constant. And so another way you can look at this, if we rearrange this equation, would be N1 over N2 is now going to be equal to V1 over V2. And we can see this is a relationship that's directly proportional, where if we increase our moles from N1 to N2, we got to increase our volume to keep this expression equal here. And so we can do that with a lot of things. So again, if things are on opposite sides, if two variables are on opposite sides, they're going to be directly proportional, where to keep these two sides constant while we increase our moles, we're going to have to increase our volume, in this case, to keep these two sides of the expression constant if everything else stays the same. If they're on the same side, well, if you increase moles, temperature would have to go down to keep this product of pressure and volume the same. Okay, and so for solutions, I've already done a bunch of screencasts on solutions, so take a look at those if you need some more work with solutions. And then also acids and bases, what I'm probably going to just do, we haven't had a test on this or anything, so I'm going to do these a little more in detail in a little bit. So that was a review of some of the third quarter stuff. Some of the stuff we've done in the fourth quarter, solutions and acid bases, I will come up with a screencast shortly.